very good day. Today I would like to make a group presentation for the subject of solid mechanics. The group presentation that we are going to do is about the straw load bearing tower that we have made the title of Cubular Tower, where this group is a group of section 1 of group 6, and our lecturer for this subject is Dr. Noriani. In our group, we consist of 3 people, which is the first one will be Lakshmi Anapropan Manodri, number matrix CN210258. The next one will be me, Solomon Jiraj Anlaki Selvam, number matrix CN210070. And the final one will be Muhammad Haris bin Ismail, number matrix CN210382.
Hi everyone, my name is Lakshmi, daughter of Manohar, and my metric number is CN210258. Today I would like to present about chapter 1, which title is Introduction of Tower. A tower is a tall and wide structure. Towers will also be constructed for observation, recreation, and telecommunication. Towers are used to support masses on top of underside in a variety of commercial applications. Without this, an exterior wall could become unstable if the weight exceeds the fabric strength, potentially resulting in the collapse of the structure. The next one is name of prototype. The straw load bearing tower that we made is known as Cubular Tower. The straw load bearing tower is named Cubular because we would like the straw load bearing tower can still arise even the high forces were applied on the straw load bearing tower. Problem background. Straw is employed because the principal structural material in straw load bearing tower constructions. The model of the tower must not weigh quite 0.7 kg and be between 25 cm long, 25 cm width and 25 cm tall to fulfill the project requirements. The project goal is to construct a steady and stable tower. Furthermore, the project recommends that the power to sustain the utmost load be used as a criterion. While investigating the very best force applied to the structure, established a design solution calculate the loading bearing tower, models normal stress, normal strain, thin cylinder, and column. The next one is problem statement. The target of this project is to simulate the load bearing tower by using the straws and to grasp what's the maximum force the straw load bearing tower may be effort. Besides that, to understand the stress strain, beam deformation and deflection, torsion, thin cylinder, strain and stress transformation, column, strain energy, and failure theories involved in the load bearing tower model. Objectives. The first point is to design and analyze the power of tower we build. The next objective is demonstrate the tower work effectively. The next one, to construct a tower out of straw that can sustain loads of up. Fourth one, to investigate the strength and versatility of straw. The next one, show the calculation and solution using solid mechanics theories that involved to the loading bearing tower model. Finally, using the SolidWorks software, we draw the design of our tower.
Hello, my name is Muhammad Haris bin Ismail. My metric numbers is CN210382. Today I'm going to present about chapter 2, literature review. Okay, tower history. Telecom Malaysia Tower, so known as TM Tower, is a 55-story, 310 meter super tall skyscraper in Kuala Lumpur, Malaysia. It is the 5th tallest building in Malaysia and its shapes represent an emergency bamboo plants. It is located on Federal Highways, Pin Highway and Jalan Pantai Baru and is served by Rapid KL Provinci LRT station. The next is Eiffel Tower. At 330 meters high, about the height of an 81-story building, the tower is the tallest building in Paris. Its base is square and measure 125 meters, 410 feet on each side. Center levels are meant to largely resist wind load, while columns are designed to primarily resist dead loads. Next, 2.3. Thin cylinder. Cylinder or spherical vessel are used in industry as tanks. A thin mechanical cylinder is a cylinder with a diameter much larger than its wall thickness. In other words, a thin mechanical cylinder or vessel is described as having a wall thickness less than 1/20 of its inner diameter. Okay, spherical vessel. A thin wall pressure vessel are one of the most typical applications of plane stress. As we can see, the spherical pressure vessel formula, and at the other side is a more circle for in-plane transformation reduced to a point. Cylindrical vessel. Consider a cylindrical pressure vessel with radius r and wall thickness d subjected to an internal gauge pressure P. Cylindrical pressure with principal stress S1 is equal to hoop stress S2 longitudinal stress. Okay, next is normal stress and normal strain. If an external force is applied to an object, then per Newton's law of motion, a reaction force is developed within the object thanks to elasticity. The magnitude of those action and reaction force are equal to and opposite to every other. Hence, the magnitude of the action or reaction force per unit area of the item is named stress. In simple language, stress is the force per unit area of an object. Okay, as I mentioned earlier, stress is defined as a force applied per unit. There are three types of stresses. One is tensile stress, which is stress that tends to stretch or elongate a material, usually acts on areas of compression. And second one, compressive stress, stress that tends to compress or shorten the material, usually acts on the area under compression. And the third one is shear stress tending to shear material, acting on a plane of stress location normal to compressive or tensile stress. Next, we have strain. It's an additional important variable since it defines the deformation of an object. Strain has 2 points, which is compressive strain, determined with the assistance of the following formula, which is compressive strain is equal to decreased long per original length. And then is tensile strain. Tensile strain are going to be determined with the assistance of the following formula, which is tensile strain is equal to increased long per original length. Okay, 2.5. Buckling in columns. Buckling of column could be a variety of deformation as a result of axial compression force. This results in bending of the column because of the instability of the column. This mode of failure is quick and hence dangerous. Long column compared to their thickness will experience elastic buckling, the same as bending spaghetti noodles. This can occur at stress level, but the final word stresses of the column, for the column that are shorter compared to their thickness, it can be concluded from the same equation above that the allowable stress of the column before buckling increase with decreasing length.
Next will be the chapter 3, that is the methodology, where in methodology we can see that it explains the various methodology that we use to gather the data and analyze which are relevant to the research. The methodology will include areas such as location of study, research, design, sampling, and sample size, types, data collection methods, and management. In methodology, it is a contextual frame for research, a logic, and a coherent system based on the views, ideas, and the value that guides the research decision making. It involves the theoretical studies of the procedure and the principle of a branch of a knowledge, and the methodology of different disciplines varies according to their historical developments. This has led to a series of methodology contains competing views on how knowledge and reality shows be understand. In addition to providing a framework of research, the methodology can also be present as a range for primarily quantitative and primarily qualitative method. Next is the flowchart. As we can see here, the flowchart has started, then we form a group, then we discuss about the topic and the title for this project, and we retrieve information from other resources and our own self by brainstorming. Next, we do project design and sketching. Then we do research and problem solving. Then we do project work and processes with testing. And finally, we summarize the project with the final result. By retrieving information, we can see here is first we do a planning. Planning is we jot down all that the lecturer has told us and all that we understand from this project. For example, like the detail of the perimeter, height, width, maximum weight of a tower that can be used, and what type of sketching we can do for these formulas that we needed to do. Then we gather all the data and collect the information from various resources, for example, like internet from our seniors and other materials. Then through our data, we know that the project needs some stuff like straw, stick tape, and sulfur tape. So we do a cost data where we buy a lot of low cost things so that it will be easy to complete the project. Then this is our sketching and product designing, where we develop our prototype with the proper characteristic like length, height, weight, perimeter of each straw, diameter, and radius of each straw. And as a result of as outline, we do our sketching on an A4 paper to choose what type of design we can do, and has done a SolidWorks software sketching too to get a better view on it. In our research and problem solving, we get to know through the sketching of the A4 paper and SolidWorks, we get to know that what type of material we can use and what kind of stuff we can use to stick each another of the material, where we get to know that the straw and the stick tape are the most best resource that we get to do and the most needy stuff in this project. And so we made the body of the project with straw and stick tape. Next is the work and the procedure. First, we bought all the straw, stick tape, silicone tape, and we have scissors with pencil. We use the pencil to mark all the measurement on the straw. And as we can see in step 3, 4, and 5, it is the stages of the straw built as a building. And in step 6 is the complete of the cubular tower. And on step 7, we can see we are doing a testing. Like so, here we do the testing to get our weight, to know how much weight that the project can withstand. And finally, we got the weight that is the maximum of withstand weight is 4 kilo of the project.
Okay, so here we can see the result that we tested using the load of 1 kilogram, 2 kilogram, 3 kilogram, and the maximum load we tested is 4 kilogram before the tower is collapsed. And we can see which is pass, and then fill in 4 kilogram, which is the maximum load. Okay, first to find the normal stress, we need to find the total area of the circle and the square. We calculate it and we get the total area, which is 82.44 cm square. And then we can find the normal stress for each of the load given. Okay. Next is normal strain. We calculate it and we get the strain for each load, and we use the Young modulus, which is E, is equal to 1.3 times 10 to the power of 9 Pascal. Next is torsion. There is no torsion on the cubular tower since there is no torque applied. And then thin cylinder. First we find the hoop stress, and this is the calculation. And then we find the longitudinal stress, and this is the calculation, and we get 0.7848 Pascal. Okay, next is discussion. According to the calculation and the experimental value, we found that the force range applied reducing the load on the support tower bus. If we change the material of the straw, the storage tower may be stronger for harder. The storage tower may be stronger for harder materials such as wood. The result shows that when a load is applied to the object, there is also a load on the object. Stress also act on the point and object when tension force the object to deform. Whereas the beam deformation occurs, more weight is applied to the beam. The result we get are both computational and experimental, less accurate because we ignore many factors, and the equipment we use not suitable for use in project due to its zero errors.
Conclusion and recommendation. In summary, the load-bearing tower should be made of hard materials such as steel or iron. Make the load-bearing tower safe to use during construction. In addition to this, the size and the shape of the support tower should be considered. Due to the shape and size of the load-bearing tower may affect the maximum mass that the load-bearing tower can support. Various tests such as stress test, shear test, elongation test, and others must be tested on load before use. Make sure the load-bearing tower is safe to use. In order to implement this project, we recommend that you use advanced equipment to measure the values so that the data we receive will be very accurately. Otherwise, there are more factors to get more detailed data. In this project, we should be consider the diameter of the straw, but because we lack the equipment to carry out this project, so that the data we receive will be different, use the correct data.